The next speaker is Vladimir Romo, who is at the School of Demography at Australian National University. He will speak on life years lost among disease-diagnosed individuals.
Correct. Good morning. And I'm saying good morning because it's 6 o'clock in the morning here in Australia. And no better time to talk about methods that are very early in the morning. Let me also say thank you to Igor and all the group from Duke for inviting me. It's really a pleasure to talk about this research. Let me share my screen. View, share. Where is it? Control L should be full screen mode. Yeah. Good. Can you see my slides?
Yeah.
Yeah, beautiful. Okay, so as I was saying, it's very good timing also because Igor ended up talking about life expectancy, and that's exactly where I'm gonna take over. It turns out that life expectancy can be very easily calculated if it's something that is happening, the population that we are studying it's something related to characteristics that are at birth or that are given at a very specific time. For example, race. You are either white or black. You are either Hispanic or non-Hispanic, etc. But for diseases, it's a little bit more complicated because we are getting diseases at very different ages. We are diagnosed a disease at different ages. So our research exactly takes over on that idea and calculates something that we call average life expectancies and average life years lost, which is the title of my talk. So life years lost for individuals that have a disease, that have been diagnosed a disease. So the outline that I gave is, it's gonna be first a little motivation of why it's important to think in terms of average for individuals that have a disease. And then I'm gonna tell you a little bit about the methods, what, why, and when should then I move on to some results that we have for Danish populations. And I'm gonna be talking mainly about results for mental disorders. We have been working on this topic for some years now. And I didn't want to touch so much other causes of death, but that's exactly the direction that we are also taking over. It's just these very preliminary results what we have for other causes of death. So as a motivation, let me just start with two definitions of life expectancy. One is the average age of death. So when we talk about life expectancy, we think, for example, of the distributions of death that you find over here. This is from the Human Mortality Database, Danish females, and you see the pattern of the death distribution, and the line that we have on a vertical over here at age 80 is the life expectancy. On average, the age of death is 80. That's one way of thinking of life expectancy. Another way of thinking of life expectancy is average survival time. And that is, if we have the survival function, that is, we start with 100% of the population and we follow them over time until they are all dead, we have the average survival time. The area under this curve is our life expectancy as well. However, if you go to Google and write life expectancy, you find Google Scholar, I'm talking, you find 1.5 million cases of articles that have been using life expectancy, but there are other articles that actually are using average life expectancy. And when you dig into this average life expectancy, this 81,000, many of them, they are talking about what you and I mentioned as life expectancy. They just want to rephrase the idea that it's an average. So it's like saying average age at death or average survival time. So it doesn't really make sense to talk about average life expectancy in those contexts. However, it makes sense to talk about average life expectancy for cases when we are studying individuals that have been diagnosed a disease. That is, when we have the situation, this is the simplest of all cases of a Markov health disease case. And then we have in one box individuals that are healthy or no mental disorder in this case. Then in the other box, we have those that transition to have a disease, mental disorder, and both groups have transitions to the absorbing state, that is the state of being dead. And there is no way out of that one. So what is interesting over here is that we have just simply 3 different transitions. And in this case, I said it's the simplest case. I'm not allowing people to get out of once they are diagnosed a disease, in this case, mental disorder. However, the model can be relaxed and you can allow it to go backwards, in the sense being healthy again, and therefore allows too many other diseases to be adopted over here. So the aim of the study is precisely to calculate life expectancies that make sense when we are talking about populations diagnosed a disorder. And what I mean by that is that populations are moving from being healthy to being unhealthy at very different ages. And we need to take this into account if we're going to be talking about life expectancies. The data that I'm going to be using and presenting for this is data from Denmark. As many of you know, since the 1970s, Denmark stopped having census. They have instead registers. So they have register for centralized civil register that gives us population counts. So it allows us to calculate persons' years. Then we have register of causes of death. That would allow us to count out which causes of death individuals are dying of. And then we have the psychiatric centralized register, which actually is hospitalization registers. And that one allows us to then look at who has been diagnosed what. So with these 3 records and linking them, then we are able to follow all individuals in the population. And then there was an issue of the way the hospitalization records were at the beginning. So you can see the data starts in the 1969, but we actually just studied the one that has the little diagonals over there, the study period 95 to 2014. As I was mentioning earlier before, we have data now for 2020. Of course, COVID has derailed our interest on this study, but we are going back to this again. So as I was mentioning, we only look at the diagonal because the previous year, actually there were issues of outpatient individuals that were not completely registered in the same way. So instead, we just look at the previous data as helping us for controlling in a way the from 95 to 2014. So again, we have these 3 states, and already we can ignore the one of transitioning from being healthy to being unhealthy and just consider the 2 that go to death. And if we have individuals healthy, or the entire population actually, and going to death, and having a disorder and going to death, then we can calculate already our life tables. So we have here the survival function. We have the straight lines are for females and males, females on red, males on blue, and the dashed lines are the ones that have been diagnosed disorder. And I'm counting from age 15 to 95. After that age, 95, our data becomes a little bit complicated to analyze several causes of death. And it's difficult to find one diagnosis alone that really identifies this individual. So we constrain the data to 15 to 95. And of course, we can calculate then 2 types of life expectancy, one for individuals with mental disorder, and I'm gonna denote that with the E that we have over there, and it's between these 2 ages, A1, which is the age of diagnosis, and tau, which is 95, that I'm cutting my data over there. And individuals without a mental disorder actually includes the entire population. And that is E with a little star over there. And then we have, again, we're gonna calculate it from age of diagnosis. That means the age just as a control group. I'm gonna use the same age of diagnosis A1 to tau. And then what we have is we can see that females live 66 years, males 62 years, and that's for the entire population. But when we compare with the diagnosed individuals, we have a gap of around 9 years for females and almost 13 years for males, more than 13 years for males, of gap between these two groups. But there is something else to learn from this graph, and that is that we have actually a little square over there. And the square is from 0 to 100% of the population on a vertical basis, and from horizontal basis, and from the vertical basis, we have from age 15 to 95. So we have this square, and so far, the life expectancy that I am showing you is the area under the curve. So what we are thinking now is to work on the area above the curve. And that's what we call the life years lost. And that is, they are lost because people die. And that, just because it's a complement of life expectancy, then we invert the E over there. And so then we have the inverted E from age A1, so the diagnosis to tau, and the same for those individuals without a mental disorder, but with a little star over there. So it's the area that we have over there, denoted on blue, and this is for the Danish males without mental disorder. And this area is very simply calculated. It can be calculated as the addition. Remember, the integral is simply a fancy way of doing an S, which it's for summing. So summing F, which in my case is the accumulation of deaths. And then, so we are accumulating deaths, and at the end we have all this blue area that we were presenting, that I was presenting just in the figure before. But there is more to it, because those deaths can be classified decomposed by causes of death. So then we have F for each of the incidence functions for each of cause of death. And what we have then is this very colorful diagram of the life years lost, which correspond to each of the colors for causes of death. So very predominant over here, the red and the blue point out. These are cancers and cardiovascular, particularly heart diseases, denoted on the blue and the red. But actually, the causes of death that I would like you to focus, because they are going to be very important when we start comparing individuals with and without a mental disorder, is alcohol misuse, the little small green color over there, suicide, and accidents. So in the black and the gray colors over there. And they are very small in this population. But the next slide is going to compare with and without the mental disorder, and you will see the big contrast between one and the other. So as I announced, the gray, black, and green are very noticeable for individuals which are found on your right with a mental disorder, both males on top, females on the bottom, and then you can see that both groups have clearly external causes of death that are very dramatic compared to the general population. So something that is very important is then to try to address those ones. I'm going to go back to point out that so far what I have been showing you is from age 15 to 95. That is, we are assuming that every single individual that is being diagnosed a disease starts at the age of 15. And that's not the case. The diagnosis of mental disorders happen, there's a peak in the teenage years, university years, education years, and then it slows down, and then there is a second peak around retirement age. So actually we have to take care of that. But what is very beautiful of this approach is that they complement each other. The life expectancy and the inverted E, or the life years lost, the addition of the two gives us exactly the number of years between age 15 and 95. That is the tau minus A1, the end up line that I had over there, and the diagnostic age at age A1. And this is true for mental disorders and for the individuals without a mental disorder. This is also nice because then we were able to control every case that we find in the mental disorders. We're going to use one from the general population, the same information. And I hope I point out that more clearly in the coming slides. So far, I was assuming that every individual started at age 15 their disorder, and that I analyzed everything from age 15, and I presented life expectancy from age 15. But that's exactly the alpha 0 to 1, the transition from being healthy to being mental disorder, or having actually any diagnosis, because this is true for any cause of death. We have to take into account this age distribution of the transition from healthy to unhealthy. And the way we do that is we construct an average life expectancy and an average life years lost. Now, for the case of the Danish case, I could calculate life expectancies pretty much at every single case where we had one individual have been diagnosed. That is 16.1, 16.7, 18.3, at every single age. But when we have aggregate age groups, say of 1 year each, single year each, then we can still weight our life expectancy at that age group by the number of cases that have been diagnosed, the new cases diagnosed at this age group. And like that, we construct this average life expectancy and average life years lost. So let me go in notation. That what that means is that in my case over here for Denmark, I have n number of individuals being diagnosed during the entire lifespan, and then I add up all these life expectancies and all these life years lost, and just divide them over the n, the number of individuals. And as I was mentioning before, this is true for the mental disorders, but every time I have one case, I'm gonna do the same counting for the stars on the bottom, that is for the general population, so that I have a control and treatment group in a way, or I can compare my individuals having a disorder with the general population. So what do we get? So the total number, the average number of years, is just as a measure that allows us to check that the individuals with mental disorders and without mental disorders, again, this is Denmark, males and females, add to the same in the general population and the individuals with a mental disorder. So in this case, for men, we have 55 years, and for females, 54. And of those years, the life expectancy, the average life expectancy without a mental disorder was 39 years for males without mental disorder, but 29 years for those with a mental disorder. That is already the average life expectancy. So now I can compare across. I'm comparing across all age groups and including all the distribution of diagnosis. So 10 years of gap between individuals with and without a mental disorder for males, and for females, it's more like 7, from 42 to 34 of life expectancy, average life expectancy. But the same we can say now for life years lost. So the advantage that the individuals without a mental disorder have is the disadvantage, the same disadvantage that the individuals with a mental disorder have. That is, there is 10 extra years lost for individuals with a mental disorder, and there is for males, and 7 years for females. And we can see the difference between 12 and 19 and 16 and 26 for each group. And this is nice, but we have in hand also the causes of death already, and it's practically the same. We are just going to be calculating average of these life years lost for each case. So let me show you a couple of slides of showing the causes of death. Again, we have the individuals without a mental disorder on the left, and on the right, we have those with mental disorder. On the top, we have men and women on the bottom. So like this, one cannot really perceive the big difference. Pretty much the pattern is the same. We have cardiovascular diseases and cancers predominant in both groups. Then we have a lower number of cases of the external causes, but slightly higher for those individuals with a mental disorder. The bubbles over here represent the different years that we had. So we used 5-year age group years, so calendar years, so 95, 99, 2000, 2004, etc. And we can see that for external causes of death for those individuals with a mental disorder, alcohol misuse has slightly been going up first and then stagnating at a higher level than the general population. Suicide has slightly going down, and accidents also slightly going down. And this is true for males and females. We can see already that heart diseases have going down in the general population. However, you don't see that prominent decline in the individuals with mental disorder. And that's something that I'm gonna go back to it at the end. And this is important, but it's difficult still to compare the two groups. So what we developed was also something that we call the excess life years lost. And that is, if we already have the average life years lost and the average life years lost for both general population and those with a mental disorder, then we just look at the difference of the two groups. That is the life years lost, the average life years lost for the general population minus the life years lost for the individuals with a mental disorder minus the general population. And what that would tell us is if we have anything that is above any cause of death that is above 0, will be telling us that we have had an excess number of life years lost due to the mental disorder. And opposite, if we have below 0 or negative values, that would be the individuals with a mental disorder have an advantage compared to the general population. And we do have a case of that, actually. So let me show you that final figure. So here, anything that is positive adds to the 10 years that I was showing that males with a mental disorder have compared to the general population, males that have had a mental disorder. And for females was 7 years. However, we can also see the bubbles representing the changes in these life years lost due to these different causes of death. And then we can see that for both cancers and neoplasms, the number of life years lost, both males and females, have been going up. That is, there are more and more cases of these non-communicable diseases in the population with a mental disorder being observed, while the external causes of death, we see that particularly suicide and accidents are going down over time for both males and females, but there is a big stagnation for alcohol misuse, and this was alcohol misuse in many different causes of death. We just we knew that alcohol was a big problem for individuals with mental disorder, so we categorized as one cause of death, including from all the different subcategories of alcohol-related mortality. And then for females, one that is worrisome, it's respiratory diseases, which has also stagnated at a high level compared to the general, higher level than the general population. It seems that initially cancer being diagnosed a mental disorder was a protective factor of cancers. But actually, we have that was in the initial years of the data. And in the last years, we see just like heart diseases, the number of non-communicable diseases is worse in the individuals with a mental disorder than in the general population. So it's a little bit worrisome because the external causes of death have gone down, but on the other hand, we have this increase in non-communicable diseases for the mental disorder group. So it's my two slides remaining over here. The difference that we see once you apply the average concept in life expectancy and life years lost is that we observe 10 years and 7 years when you compare males and females in the dementia, in the group with mental disorder versus the general population. We think this is closer to the if we were only to take individuals at age 15 or at age 45, very subjective age that we select over there, this is a much better comparison group. Most of the life years lost are still being lost in this case. We can also, the analysis helps us to point out that alcohol misuse is very bad for males, while respiratory diseases is very bad for females that have been diagnosed a mental disorder. And over time, we see the external causes of death going down, suicide and accidents particularly, but we see an increase in the non-communicable diseases. So this is, I believe, one of my last slides, the conclusions. the idea, I wanted to present this to the group because I think this concept of the average life expectancy and average life years lost is suitable for any time that we are interested to study populations that are diagnosed a disorder, being this a mental disorder, being this Alzheimer, being this any other disease. And we are trying to move in different diseases. It's just sometimes we are finding things that are really unexpected, and it makes us a little bit have hiccups on the way, but and needing specialists of each of these different diseases. But our goal is to have a buffet of the options that we observe when we calculate these average life expectancies. The methodology we first pointed out when we arrived to Australia. My wife was the first author. I was the last author putting out the methodology, and she's an expert on mental disorders. So in the Lancet Psychiatry, we put out the methodology. But since then, colleagues from interested on mental disorders, they really embraced this idea. And we had following papers in schizophrenia, Lancet, and PLOS ONE, using the same idea, the same concept. And I will be very happy to see it that is moving now to Alzheimer and to other neurological diseases, and very interested to collaborate, of course. I hope the slides will be shared, and I on purpose left 5 minutes to see if there is any question that I could address in this moment. If not, here's my address. I'm very happy to talk with all of you. Thank you for your attention.
One question that I have is the definition of mental disorder and how sensitive it is to the precise definition you use.
Yeah, well, that's a good question also, because there is no more than for the diagnosis, for the causes of death. We discovered that there was a big problem on the causes of death due to mental disorder. And the experts in the group, that first paper, were a lot of experts on mental disorders, and they were mentioning nobody dies of a mental disorder per se. These are actual diagnoses that we are observing. We depended very much on what hospitalization was records we had. So we, in the first paper, we included any mental disorder. So all mental disorders were included in there. In the following papers, we were, just as you point out, there is very different talking about bipolar disorder or other kind of, or the schizophrenia. And so in the following papers that I was mentioning over there, we go down and do the same type of analysis for each disorder individually. And that helped a little bit address exactly the problem that we were putting in one bag, all the disorders together.
So they could range from anxiety, a few visits to a psychologist, to bipolar exacerbations that
and it could also, indeed, and it could also vary from individuals being diagnosed early to individuals coming at a very late stage in the diagnosis of the mental disorder. So we couldn't control, we didn't want to control that in that first paper, but in the following papers, I invite people to see them. Especially in the Lancet, when we really go and point out individual mental disorders, and then it's a little bit better assessment of that. Yeah.
Okay, well, great. Thank you. I hope I didn't crowd out other questions, but we are out of time. Oh, we have 1 minute, I guess, or half a minute.
Very fast answer.
Okay, but we can maybe, this can be continued in the discussion tomorrow and so forth.